Okay, let's do some practice problems. So, what is the concentration? A lot of doing problems in chemistry is just interpreting the English and trying to figure out what the real problem is. So, concentration in chemistry means molarity. In other subjects, like in biology, a lot of times they use percents, but in chemistry it means moles per liter. So, we want to know how many moles per liter of a solution of sodium sulfate made of 3.6 grams of sodium sulfate in 500 milliliters of solution. So we're going to start with 3.6 grams of sodium sulfate. And you got to know the formula for sodium sulfate, which we've already talked about a whole bunch. So that's sodium sulfate. If you're ever in doubt, you can look it up, double check your answer and see. Pretty much as soon as you're in grams, you need to change the moles always. So look up the molar mass of sodium sulfate, and I'll calculate that too. It's 142 grams per mole. Okay, and then we need to figure out moles per liter. So the grams have canceled out. We've found our moles. Now we need to find our liters. So it tells us right here we have 500 milliliters of solution. So I'm going to change that to liters. So that's a half liter. So multiply everything on the top, which is going to be really easy, and then divide by everything on the bottom. And you get two significant figures. That's 0.051 molar sodium sulfate. And as you're studying for tests and quizzes down the road, I would try these problems again on your own now that you know how to do this, and cover up your answers and see if you can set up the problem on your own, and don't cheat. Make sure you look at the answer after the fact. Hide it from yourself or something so you can make sure you're doing the problem correctly by yourself. Okay, we want to know how many moles of Ki, potassium iodide, are in 20 milliliters of a 2.3 molar solution. So the rule is don't start a problem with molarity if there's anything else there. So we have 0.02 liters of Ki. And we want to change from liters to moles. So this is a little bit tricky. You're not used to doing this yet, but this means 2.3 moles per every 1 liter. So that's a conversion factor that I'm going to use. So there's 1 liter. There's 2.3 moles of Ki. And we want to know how many moles there are. Oh, so we're done because we're ending in moles. So 0.02, I'm going to get rid of this so it's not so big. 0.02 times 2.3 is 0.046 moles of Ki. All right, so let's keep going. All right, how many grams? That's what you're looking for. Of cobalt 2 chloride, COCl2, are in 50 milliliters of a 0.35 molar solution. Okay, what's the rule? Never start a problem with molarity. So we're going to start with milliliters, which I'm going to change to liters. You may wonder why in the world we always do that. Why not just give us liters? Well, most of the time in the lab we use milliliters instead of liters, so that's why we do this. And molarity is in the unit of liters, so we have to do the conversion back and forth. All right, for every 1 liter of solution you have 0.35 moles of that solution. And we want to get to grams, so we know we have to cancel out moles. So there's 1 mole of cobalt chloride. I got to look up the molar mass again. So we have cobalt 2 chloride. And that is, what's his molar mass? 129.8. So let's just call it 130. So multiply everything on the top. Again, don't just depend on me. Make sure you know how to put this in your calculator properly. And I'd use a real calculator. Don't use your phone all the time because they're not very efficient. So if I actually wanted to make this solution, this 0.35 molar solution, it would take 2.3 grams for every 50 milliliters. Okay, I would encourage you to pause the video right here and try to do the last 3 problems on your own in pencil, preferably. So see if you can do those on your own and then come back. Okay, number 4 is a little funky. There's not a whole lot to do here because I already gave you the concentration, but this is like the example from your notes. So if you dump potassium carbonate into water, you have 2 potassiums that fall off and 1 carbonate. So the whole solution, it says, is 0.25 molar. However, the whole thing is 0.25 molar. If you throw it down in the water, you have 2 potassiums for every 1 molecule. So you get 0.50, not 0.25. There's only 1 carbonate that falls down in there, so you can just leave that. 0.25 molar. Okay, what volume of 0.5 molar sodium hydroxide would you need to have if you have 0.12 grams of sodium hydroxide? I automatically start with grams because I know I'm not supposed to start with molarity. Is this in our notes? Nope, this is different. Okay. Wouldn't it hurt to do it again? Okay, what volume? All right, so this is a little tricky again. We have 0.5 moles per liter. That's what that means. So you have to interpret that and how you're going to use that. Or 1 liter is 0.5 moles. All right, here's the scoop. You have moles in the top here. So you have to divide by moles in the bottom. How many moles do you have? 0.5. Per how many liters? 1 liter. Multiply the top, divide by the bottom. Ooh, very small amount, 0.006 liters. That's the same thing as 6 milliliters. All right, so for the last one here, we have something kind of strange because I told you can't start a problem with molarity, but that's the only thing you have. So we want to know how many grams would you need? Well, I should say if you're making 1 liter. All right, so we have 0.20 moles of nickel 2 nitrate for every 1 liter. We don't really, we can cancel out the liters, but it really doesn't matter. So for every 1 mole of nickel 2 nitrate, we want to know how many grams that would be. All right, so I have to look up the molar mass of nickel 2 nitrate. And it is 183. So this is really an incomplete example because I didn't tell you how many milliliters of this stuff you're even trying to make. So that's my fault. But if you multiply the top, you have 2/10 of 183, or 0.2 times 183. And you get 36.6 grams if you wanted to make a liter of this.